All right, we're going to be looking at practice test 2, problem number 1. As I've stated before, to get the best effect out of these problems, whenever I ask a question or I ask you to calculate something, pause the video, take time to try it yourself to give a good effort, and then continue the video. We have two masses on an incline. Mass A, 100 kilograms on the left side of the incline, and mass B, 50 kilograms on the right side. We're given the two angles, and we're asked what the acceleration of the system will be. I have put an acceleration symbol on there. That is an assumed acceleration. The mathematics will tell us whether the direction is correct. What is Newton's second law? Of course, that's equal to the sum of the forces is equal to the mass times acceleration. Now we need to write Newton's law, second law of motion for each mass. So let's draw a free body diagram for mass A. As you see here, I've completed the free body diagram for mass A. I show the force of tension from the connecting rope, the normal force for mass A, and the gravitational force for mass A. Those are the forces acting on that mass. Draw a free body diagram for mass B. Okay, I show the free body diagram for mass B. We have the force of tension, the normal force on mass B, and the force of gravity on mass B. What are the components of the force of gravity on mass A? We have the force GAX, the X component, which is simply the force of gravity on mass A times the sine of theta A. And then the Y component, the force of gravity on the A mass cosine theta A. You should be able to convince yourself that it is a sine theta A and a cosine theta A. Sine theta A for X, cosine theta A for the Y. What about the force of gravity on mass B? Well, force of gravity on mass B, the X component is force of gravity on B, sine theta B, and for the Y component, force of gravity B, cosine theta B. What is Newton's second law for the X and Y components of mass A? Okay, let's look at your free body diagram. We're looking at the X component. That's going to be equal to the mass times the acceleration. And then we have Ft in the positive X direction minus the X component of gravity in the X direction will equal to the mass times acceleration. What about the Y component? There is no Y motion, there's only X motion. So we have that the force normal in the A direction minus the gravitational force in the Y direction must equal 0. What about the second law for the components of mass B? Same thing, now we have that Ft is now in the minus X direction, FGB in the positive direction, sine theta B, that's going to be equal to the acceleration times the mass B. And then of course the Y component, the normal force minus the force of gravity on mass B, cosine theta B will be equal to 0. Solve for the acceleration. I have two equations. I have the equation for mass A and I have the equation for mass b. Now there are two ways you can approach the solution. One is to solve for ft and substitute it back into one of the equations, or we can simply add the two equations together. We can add the left-hand sides together and then add the right-hand sides together. All right. And we've come out with acceleration is equal to the equation below. If we substitute in the numbers, we get minus 0.44 meters per second squared. What does the minus sign mean on the minus 0.44 meters per second squared? You should be able to figure that out.